In this video, we're going to look at how to do op-amp circuits in PSpice. And so this is going to be relevant to our second lab in ENG 301. So I've already created a blank project here, and so it's important to note that you want to create a project as opposed to a design, otherwise you're not going to have all of the simulation capabilities. So the first thing we're going to want to do is place a part, so I can either hit P or I can come over here and click this IC symbol. Now what we're going to be using in this simulation, in this example, is an ideal op-amp. So that's going to be in the analog library, and so I can either search through this alphabetical list, or since I know the name, I can just type in op-amp. And so here, remember, we get a little preview of what we're going to see. So I'm going to go ahead and double click here. That's going to pop me over to our sort of circuit space and place my ideal op-amp. So notice we have two input terminals and one output terminal. And so this is going to behave just like the ideal op-amp that we saw in the notes. So keep in mind, if you want, you can flip this around. So notice that our positive terminal is on the top and our negative terminal is on the bottom. So that's opposite of how we typically draw it in the notes. So if I want, I can select this and I can click V to flip that vertically. We can also do H to flip parts horizontally, or we could click R to rotate parts. So that's what we're going to be dealing with today, but let me just mention, if you look in your lab instructions, you're actually going to be using a separate part when you do your pre-lab. So that part is going to be in this eval library, and so this is again mentioned in your pre-lab, but it's going to be UA741. And so here we can see again this is an op-amp, but notice we have a few more connections. So let me just place this here and mention a few things before we proceed. And so I'm going to hit escape to stop placing parts, and I'm going to click I to zoom in. So notice, compared to our ideal op-amp, we have a lot more connections. We still have our two inputs, we still have our output, but now we also have this V minus and this V plus. And so what these are our power sources that are powering the op-amp. And we said usually we don't draw that out because we don't want to sort of clutter up our circuit, but it's very important to include in our simulation with this UA741, and also, of course, when we're wiring the circuit. We also have these offset pins, OS2 and OS1. For this lab, we're not going to be dealing with that, so you can essentially just ignore that. And you'll also notice that each of these sort of pins here has a number by it. So for instance, our inputs are 2 and 3, our output is 6, and these two powers are 4 and 7. So we'll come back and we'll talk about that in a later video, but essentially that's just related to the physical location of the pins on our integrated circuit. Okay, so this is what you're going to use in your pre-lab, but like I mentioned, we're just going to use our ideal op-amp in this introductory video here. So let's say we want to make a non-inverting amplifier configuration. Well, so if we look at our notes, we know we're going to need to add some resistors and a voltage source. So let's go ahead and do that. So if you want, you can select all of your libraries and you can just search for your parts. So for instance, resistors are, or you could go to the specific library and find it there as well. So we're going to need two resistors, one attached to our inverting terminal and one here that's going to be feedback between our output and our inverting terminal. So now that I'm done placing that, I'm going to hit escape. We're also going to need a DC voltage source, so VDC is going to give us our, so I must not have that selected, yeah, so it's in our source library. So there's our VDC. So I can, remember I can choose to rotate this if I want. However you want to place that, in this case, let's say I just want to leave it like this, so I can do that. And so that's going to be sort of our input voltage to our non-inverting terminal. Okay, escape to get rid of that. So let's go ahead and wire some of this up. So I'm going to hit W as a shortcut, but remember you can also do this from the side panel over there on the right. So this R1 is connected to our inverting terminal. Our battery is connected to our non-inverting terminal. Our R2 is connected between our inverting terminal and our output. And so I can, oops, let's not do that. Can make it sort of come a little further out to the right there. Okay, so one other key thing that we're missing here, so I'm going to hit escape to stop wiring, is our ground. So remember in PSpice we always need to include our ground. So I'm going to hit G as the shortcut for that. it shouldn't make a difference as far as which library you pull this from, but usually capsim source is what it's going to default to. As long as you're seeing this over here in the preview screen, you should be all right. So I'm going to place my ground over here. So let's put it right under the source, hit escape, W to go back to wiring. So I'm going to wire this bottom side of our source to ground, and then we also need to connect this resistor R1 to ground. So I'm going to connect this to ground as well. Okay, escape to stop wiring. And so remember, I can sort of move parts around, so this voltage kind of got covered up by that wire, so I can move that over here if I want. So let's see if we can zoom in and still see everything. All right, not quite, so let's zoom back out. Okay, so now let's set values. So let's make our input voltage, I don't know, let's make it 4. Something nice and easy to deal with. So it's going to be 4 volts DC input here. So now remember, we can set our gain of this amplifier by adjusting these resistance values R1 and R2. So let's say we change this R2 to be a value of 5K. So 5K is going to be 5K ohms. And so if we look at the equation in the notes, we can see from this we have RF divided by R1 is 5, plus 1 is 6. So our gain for this our amplifier is going to be 6. So what we expect then is to have 6 times 4 over here on the output, or 24. So remember, one other thing that we've mentioned previously that can be useful to sort of keep track of your nodes is this thing called our net alias. So I can put a net alias, and I can maybe call this our output, or if I wanted to, I could call that V out. And so I can put that right here. And so that's just going to make it easier for when I'm trying to identify this output voltage later on. So notice this node is now called output, whereas these other nodes are going to have sort of the default names, which are these long numbers. So 00190 and 00194. So it just makes it a little easier to recognize. Okay, so now our circuit looks complete, so we need to now set up a simulation profile. So we come up here and we click New Simulation Profile. For this one, we're just going to do a simple bias point, so you can call that whatever you like. Just call it bias point so it's easier to tell when I'm choosing between simulation profiles. So remember, for bias point from this drop-down menu, we just select bias point. Typically, we're not going to have to mess with anything here, so we just click OK. Okay, so now notice we are no longer grayed out with our play button, so we're going to go ahead and run this simulation. And what we're going to see is a new window is going to pop up with our PSpice analysis. Takes it a while, and so we notice our simulation is 100% complete here. But we still have this thing where it has just defaulted to this blank page. And so remember, that's because it defaults to this page where it's not showing any, where it shows our transient analysis, but we don't have anything that we can plot over time. So if we want to see sort of just the notes of our output, the text of it, we can click here to view our simulation output file. And so this is going to show us a lot of our connection details and stuff like that, but in this case, what we're interested in is our output voltage. Okay, so notice here, our output voltage, our node voltage at output was 15. Well, that's kind of interesting. We expected it to be 24, so let's take a closer look at that. So let me minimize this for a second. Remember, we can also come over here and we can select V to see in real time our output voltages or our node voltages. So here we have 4, here we have 2.5, and here at our output we have 15. So let's take a closer look at why we're getting that 15 instead of the expected 24. So let me double click on our op amp, and that's going to open sort of our schematic page for a more detailed setup. So if we scroll down here, we notice that our V negative and our V positive are set to negative and positive 15 volts by default. And so remember, as we talked about in the notes, we have this thing called saturation, where for an ideal op amp, our output cannot exceed the output rails. So because this is just a simulation and we're not worried about the powers or affecting the devices, we could either come in here and increase these voltages, or if we come back to our circuit, we could also decrease this input or change this gain. One note about increasing these voltages, So you want to be careful not to exceed the specifications given for the particular op amp you're using. So like I mentioned, in this case, it's a simulation, so we're not going to hurt anything. So we could take this up to 500 volts if we wanted. But for a real op amp, you might not want to do that. So let's, for instance, just leave this at the plus and minus 15 for now. Again, you could change that if you wanted. But let's instead just change this down to, let's say, 2 volts. So now with our input being 2 volts, we still have our gain set at 6, so we would expect 2 times 6, an output of 12 volts. So we can play our simulation again, and this time hopefully we'll see the correct output. Okay, so our simulation is 100% complete. So again, we can click over here to view our simulation results. And if we scroll down here, we now see we get our expected output of 12 volts because we're not having that issue with our saturation. And so similarly, we can click on this V. And so this is something where PSpice sometimes personally gets a little annoying, in my opinion, is because notice that these voltages haven't updated from when we ran our previous simulation. So be cautious trusting these values. If you're ever uncertain, a good way to sort of get around that is to just restart PSpice entirely. But whenever possible, it's usually better to rely on these output files, whether it's the simulation results or the plotting data here. So we're going to come back in some other videos and we're going to look at some other things we can do with this circuit, particularly our transient analysis. And we're also going to talk about how to sweep resistor values.